In a reaction related to Dibel, we're going to be talking about organocopper lithium reagents, and what these do is they will take an acid chloride and convert them into a ketone using what's called an organocopper lithium reagent. Now the way this reagent is made is by taking an alkyl halide, turning it into an alkyl lithium compound, and then reacting two equivalents of this alkyl lithium to form a organocopper lithium reagent. The benefit of this is that it is a very mild form of negatively charged carbon, which allows for the production of the ketone without further production of tertiary alcohols. So let me show you a summary of that over here. So what happens is that the negatively charged ion here will come from the organocopper lithium, and it will attack the acid chloride and produce a ketone. Now what does not happen is that we don't get a further equivalent of negatively charged carbon coming in and producing a tertiary alcohol. This will happen if we use a Grignard reagent, which is the other form of negatively charged carbon that we have previously talked about. This is not considered to be a mild form of negatively charged carbon. What it will do is it will form the ketone first by attacking with the negatively charged carbon, then another equivalent of this will come in and attack the ketone and produce a fair amount of this tertiary alcohol. If we just use the organocopper lithium reagent, however, we end up just getting the single ketone without any more negatively charged carbons coming in and producing the tertiary alcohol like the Grignard reagent does. Alright, let's talk a little bit about the mechanism here, and you can see that it does follow the same pattern as what we've been talking about. We've got the Y here and the X negative, which will be this with a negative charge on it. And so the Y is Cl, you've got this with a negative charge, and that group, the carbon group or alkyl group will be where the X is, and the Y minus will be Cl minus. So it's following the same negative mechanism as what Dibel followed, for example. Let's take a look at the mechanism here. So in the first step, we consider the organocopper lithium reagent to be just a negatively charged carbon, where the negative charge is on the carbon, which is connected to the copper. And it's the same mechanism as we saw for Dibel, where the negative jumps up on the oxygen, the chlorine leaves the Cl minus, and we end up with our ketone and Cl minus. One of the most common questions I get is, well, if there's two equivalents of alkyl group here on the copper lithium, why does only one attack? Well, that's part of the reason for it being mild, is that once it releases one of these negatively charged carbons, the rest of it is just inactive and no longer is going to be able to produce any more negatively charged carbons here. The rest of it just sort of goes away and can't really do anything else. So it's only ever going to produce just a single equivalent of C negative compound here. And we're not really interested in what happens to the rest of it. All we know is that it doesn't react with either the acid chloride or the ketone, which is really what we wanted in the first place. But let me say just one other thing about the two equivalents business here. If we go back to the way this is made, I made the comment that we make the alkyl lithium first, then we use two equivalents of the alkyl lithium to produce our organocopper lithium reagent. So what you can see here is that since we're only going to end up using one of these equivalents of R primed, that if this is a very expensive alkyl bromide to begin with, that you're going to end up losing half of it, because you're going to use two equivalents to produce your organocopper lithium reagent, but only half of it will actually end up reacting to form the desired ketone that you want. So that's consideration that's going to need to be made if you're using a very expensive alkyl halide as your starting material. Alright, so there's your There's your reaction, and you can see we're just again using the single equivalent of C minus here to come in and react, and since it is such a mild form of C minus, we don't get further reaction of the ketone to form a tertiary alcohol.